Hey everyone, welcome back to the lab. In this video, we're going to be talking about string-backed enums in F#. So recently I've been playing around with server-side rendering in F#. In one experiment, I tried out HTMX, which utilizes element IDs to uniquely target the HTML element to swap or act on. This means if you get the element ID wrong, your page interaction breaks, and that's pretty bad. So thinking about how to prevent this, I figured a type-safe collection of the finite potential elements I had on my page was a pretty good way to model this. This made me think discriminated unions, and since the ID was a string, why not a string-backed enum, which is essentially a DU with a single value. So you can imagine you could use like constant strings, but you know, there could be infinite constant strings. You don't get any IntelliSense when you're like trying to find the string for you. So this is why people reach for enums, because it's a finite list of the possible options, which gives you IntelliSense, gives you these, definitions all in the same place, and serves as that constant with a little bit more organization. And since this DU that we're trying to use, is really just a DU to a single value, it's just a list of typed values, a string-backed enum kind of makes sense. And so this serves several purposes for us, provides a lot of benefits. This creates a type enumerating the page's potential targets. So again, we can get a single source of truth of all the different values that we care about. We get our IntelliSense, things like that. It allows for match statements in their build time checks, ensuring you've handled each one. So we don't get this issue where we have switch statements everywhere that are like handling things, and then we just have to rely on like the runtime error of the default, where if we miss something, in this case, if we were to add a new option, then we would get build time compiler check errors everywhere saying like, hey, you forgot to handle this option, which is really great for preventing these runtime errors. And of course, the biggest thing is we get the single source of truth for this type to string ID and vice versa, so that we at least are constraining our options, our room for error, when we're going into this kind of string world of HTML. Alas, F# does not currently support string-backed enums natively. Functional performance purists are probably saying, duh, if you are checking the value of an enum directly, you are doing it wrong. But I want to do it anyway, for science, humanity, and simplicity. And yeah, one of the biggest reasons I've heard of why you don't want to be checking enums directly, or why it's okay for enums to be int backed, even though ints mean nothing to humans, is that this is very performant. And so theoretically, what you're trying to do with enums anyway is just kind of create a discriminated union of sorts in languages that don't have it, which I think is fine. But I think it breaks the law of simplicity, where if we're trying to debug something, we want the value to be so descriptive that if we see it, we can know what that means. And so in the case of my HTMX page, if I'm sending the wrong ID, I want to know what that ID is so that I can trace it back in the code. And so having a string ID that's basically unique, at least within the context of this page, is really easy, because I can just go look at my code bases and there's going to be like 11 times it is. But if it's the value 1 or 2, I have no idea where that came from. And so that's why I'm kind of like against these int-backed enums. I just don't think they're that useful. Anyway, so in this post, we'll explore how to define a string-backed enum in F#. And the question we're trying to solve is how to simply define a string-backed enum in F#. And as we'll see, it's just not quite as easy as you'd want. Okay, so here's my overall answer. So I experimented with several ways to try and achieve a string-backed enum-like experience that offers a simple definition and usage pattern. Basically, what I want is to get an enum and get out a string. And then I want to be able to give the enum a string and get out either the enum if it matches, or just none if it doesn't. Because you can imagine that you could get any kind of string and only a few strings are actually going to match what the enum is. So we're going to handle that nicely. After several iterations, I've landed on a pretty good solution that offers a decent balance using string literals. In this post, we'll explore a couple options and my journey to landing on my current best solution. All right, let's start with the dictionary solution. So my first solution here to this was to use a different type entirely, which maps my int-backed enums to strings and surfaced useful helper methods. So in this, we're defining an enum, and then we're constructing this type strenum with a match function from enum to string. So here we have our enum, which is int-backed, and then we're creating my strenum, which has its generic type of enum it takes in, and then we provide a function here, e, which matches e with these here, and which basically maps it to a string. Now this works fine and is pretty simple to use here, though this may not be like the most intuitive thing you'd think about. But there is a bit of complexity under the hood, including lots of reflection. The requirement for it to be an enum, so if you change this to like an actual DU, this wouldn't necessarily work. And the requirement for it to be, and a lot of internal processing. And so the full source code is here, where I was trying to do this with HTMX. And we can see that it's rather long. We're using some reflection-y things with the enum.getNames. We're doing a lot of like from random t to try to parse the enum so it's easy to break this thing. We got all this like type narrowing kind of stuff in here. And then at the end of the day, we're basically holding 2 dicts in memory, all just to get these, get enum and get string values, which we ideally would just have a strenum. So quite a lot of faff in here to just get this functionality. And so the usage is simple, but the logic isn't co-located. It's all in here. And it seems like a lot of stuff to just get a simple string backed enum out. And I'm sure there's edge cases that I didn't even run into in this thing. And it just seems like a lot. Asking for help. So my previous solution worked, but it didn't feel good. So it felt like there was a better way, but I just couldn't think of any. So I reached out to r/f# on Reddit for help. After lots of discussion and several different solutions, I think I landed on a relatively simple solution that I wouldn't feel too bad using. And so here's the thread here. If you're in F#, definitely join r/f#. There is a lot of smart people on here who are very willing to help. And thanks everyone for, commenting on that and giving me your suggestions. Okay, now we're going to talk about string-backed enums with literals. So in this version, we are using string literals, which allow us to use these values directly in match cases. So if you just use strings by themselves and they're not literals, then you're going to have to do like s when s equals this, which is kind of a lot of boilerplate to write, especially if you have a lot of cases, easy to kind of mess up. So we're kind of using string literals, but it has good and bad. So the good part is that the match cases are still relatively easy to write. We have no room for mistyping strings, bar versus bar, which is what you would do if you weren't using kind of like a central single source of truth for the value of the ID. And it's relatively small code. So here's the whole code, which is much smaller than that other thing I showed you. And we're not really using reflection or anything like that. So that's good too. Now the problem is, this isn't perfect. Like the literal can't really be declared inside the type. Like I can't have a literal down here, which means that, this is going to be outside the type. So it's not co-located, but I think if you're only using this literal inside of this thing, it's decently okay for this, because you would probably just move them around together, but not perfect. If you're curious and want to play around with this, I do have this in a replit for when I was kind of testing out different options. So you can get that here, and it's linked in my post next. So this is the best solution I found yet for string-backed enums in F#. That said, I'm always on the hunt for even simpler solutions. Like ideally, we just get string-backed enums natively in F#. Yes, functional performance purists will tell me that that's stupid, but like this is something I want. So like, why can't the language just do this? So let me know if you have thoughts for how to do this better so I can further simplify it in my future projects, because I have a feeling I'm going to be using this a lot in HTMX to add some type safety in there. And the simpler it gets, the simpler my whole project gets. So if you like this post, you might also like simple interactive islands with F# and HTMX, the state of F# 2023, if you're just new to F#, and F# like records in Python, if you're trying to understand how to do simple things in F# and port them to other languages. That's it for this video. Thanks for watching, and I'll see you in the next one.